latent cooling. Latent cooling is what just kind of disappears. You get no real value out of those BTUs. And that is affected by a number of conditions, by those design parameters we were just talking about. And so the amount of BTUs that you deliver that actually affects the temperature, that is called sensible, because you're actually sensing it. It actually has an effect on the temperature of the room. So we've got the total BTUs, okay? Sensible us. This engineer is telling us sensible, we need at least 20,664 based on their calculations. So the way we determine our sensible, it's provided by this number. You can see over here, MBH, that's thousands BTUs per hour, so 39.3 thousand BTUs per hour. Next is this calculation, sensible, as a percentage. So this is a multiplier that you're going to use to figure out your sensible cooling. So all you simply do to figure out your sensible cooling is we'll take the 39.3 total that we have here, and we're going to multiply it by 0.66, which is our sensible ratio, and we actually deliver 25.9 at these design conditions. We deliver 25.9 thousand BTUs, or 25,938 BTUs at the engineer's selected design parameters. So going back to our design conditions, they want 20,000 BTUs. We're delivering 25. We're good. We are going to be able to cover the heat load the engineer has calculated.
Can I point out one more thing that was very helpful is,
of course,
I know I've had customers and I've come to you and that said, Marina, I just want it to be the standard. And the standard is, I just want to mention in the video that even though a customer may come to you and say, you know, this, I want the standard, and some of us may not know what the standard is, we still want to ask him for it, because what he considers the standard may not be what we've seen in documentation as a standard. Correct.
And you're talking about the design commit. Yes, you're talking about the customer saying, I want the standard design conditions.
Yes.
And that's exactly right. We'll talk about that a little bit. So every piece of equipment, or every combination of equipment tonnage, has a AHRI nominal rating. Okay, so when we call it a 3.5 ton system, obviously as the design condition changes, it's going to produce drastically different amounts of cooling. So, you know, if we look at this example right here, just going in this bottom right corner, if it's 75 degrees and I'm running it at low speed at 1139 CFM, and it's 115 out and the wet bulb is 59 degrees, I'm going to get 29.2 total MBUs of cooling. So it's no longer a 3.5 ton system. That's now a 2.5 ton system, essentially. So to create a baseline so that we kind of have a shorthand to compare equipment performance, the AHRI, which is the institute that verifies and validates that equipment does what it says, what the manufacturer says it does, they created the standard of 95, what is it, 80, let's see, it's right here, 95, 80, 67. So 95 outdoor, 80 dry bulb, 67 wet bulb, and that's this green box, okay? So that is what our AHRI standard is, and that's where, when we call it a 3.5 ton system, that's where it's got to perform to call it a 3.5 ton. But to Marina's point, every area that we cover has different standards. In Phoenix, we typically see it designed at 115 because, you know, we're a hot area, and 75 degrees dry bulb and 67 wet bulb, or 63, you see a lot. So what may be standard for the nation is not going to be standard for you locally. So absolutely, if they want expanded cooling data, they must provide the design conditions they want to see it at. because of how much that affects it.
Thank you.
Okay. All right, so that's example one of kind of a system, a simple residential system, so we can get familiar with how to use expanded cooling data. Because at the end of the day, what we're trying to do is provide enough BTUs of cooling to satisfy that heat load. So the next example we're going to look at, this is a little bit of a more complicated schedule, and we're going to get into how we would do this takeoff. Oh, and these are ductless systems. I didn't realize that. I thought we were doing conventional. So, oh, this may not be the best example because these are using multi-zone, which I don't think we're.
Okay.
I don't think we want to get into multi-zone quite yet because that's a lot more complicated. So let's jump to the next example we were talking about. So here's another residential example. Much different view. You know, the way it looks doesn't look like, we don't have a nice little box that tells us that equipment. So here we're going to have to kind of look for the information we need. So fresh air ventilation, that's not something we need to worry about when we're selecting equipment. So we're going to keep looking, and yeah, economizer. So we got fresh air. So what we're looking for, oh, and now includes unlimited minutes, is something that tells us the equipment schedule. So right here you see mechanical equipment schedule. So this is kind of what we're looking for, is what the equipment selection is. So here we have zone name 1, HP1 offices. That's telling us what this is covering. It gives us a general idea of what the basis of design is. So the basis of design, the equipment that the engineer has selected to satisfy this, is our Daikin 2 MXS, 1.5 ton, 18 points here. It looks like we might get into multi-zone in this example as well. So this is what they've selected as the condensing unit. This is what they want to provide for sensible cooling, what they want to provide for heating. Oh, and I will say the example I've been giving has exclusively been looking at the cooling. That's kind of an Arizona thing because we have such minimal heat demands. Mm-hmm. We typically, here our engineers don't seem to be as interested in making sure that the heating, especially in heat pumps, that the heating demand is satisfied. Because if we can satisfy the cooling demand with that equipment, it's going to be sized well enough in the heating season for a heat pump to do the same thing. So that's why you see me focus exclusively on the cooling side. But you can run these exact same calculations on the heating side. You don't. The heating side is much simpler. Okay, so that's what we're looking at. This is what the engineers selected, and this is what they want. Now, here, the engineer is not providing design conditions. We don't see anywhere where they're telling us outdoor temperature, dry bulb, wet bulb. So it's not here in the equipment schedule. So this is where we kind of have to search. And we come down here and we see mechanical notes, and we see as we start, okay, mechanical design is based on floor plan, detail provided, okay. This is kind of, it is the responsibility of architect, draft, and general contractor to verify. This is just kind of some legalese used with the manual JLO calculations. All mechanical contracting work shall comply with. Okay, so we're not doing the work. That's up to the contractor to verify that they comply with those codes and regulations. But here, mechanical design based on the following conditions: 110 outdoor, 72 indoor dry bulbs, 66 outdoor wet bulbs, 63 indoor dry bulb, and 32 outdoor for heating. So here we've got all that information we needed. It's just not in the same place on the mechanical schedule. So that's kind of where it was just an example I wanted to use to show kind of how you can look for that information. Now, in some scenarios, it will not be anywhere on the drawings. In that case, what we would do is we would use the standard AHRI, those that we talked about, the 95, 80, 67, and then we would qualify and say, you know, expanded cooling per standard or AHRI standard. Okay, so here we're looking at, like, let's look at this ductless system. So how do we know if this ductless system meets this 11,998 sensible cooling at these design conditions? So we are going to look at the engineering manual. So we want the MXS. There we go, MXS multi-port engineering data. All right, and we are going to go down to, if you look at the table of contents, it's going to tell you that capacity tables is what we're looking for. So the 2MXS18 and MVJU, that's what the engineer has selected as the basis of design. And so you can, from the engineering manual, you can actually just click on this and it's going to take you in. And then you've got this, by now, a little bit familiar chart where you can see across the top, you've got your indoor air temps. And then they do it a little different on the Daikin side, is you've got your indoor temps and you've got your outdoor temps. And then I believe you have a nominal. Yeah, they don't really account for wet bulb. So with a multi-zone situation, what we've got to do is figure out what the combination of the indoor units is. So in this case, they've got FC1A and FC1B. Those are two individual heads that are the CTX G09s. So over here, you've got individual heads. And here you start to see where, like, if you put two CTX SO7s, a CTX SO7 and an FTX 09, so you would just go down, scrolling through this column until you find this combination of two CTXGs. Which I don't see. So that may not have been the best example.
I think, are those the ones that have been obsolete, like we've moved to another model? I want to say it's FTX.
And that may be the case.
Okay.
So, yeah, I would have to look that up. So I guess let's move on for the sake of the intent of this call. So here, you've got in the next section of the mechanical schedule, you've got the RTU1 and RTU2. So they've selected, fortunately for us, a Daikin DSH060. So that's a heat pump. So we could go, and here's our data that they've provided. So here we would go to daikinac.com, where we go for all of our commercial Daikin equipment, and we'd select under the light commercial the package heat pumps, and we'd go find that DSH 060. So we know that's a from our know, we know it's a DSH series, and the 060 tells it's a 5-ton. So spec sheets, and then we're just going to go down again to our expanded cooling data. So here you've got the same charts that we've seen before. We're going to go down to the 5-ton version right here, and go back to our notes here from the engineer. We're looking for a 110, 72, 63. So let me flip this sideways so we can read it and zoom in. So here we've got a 5-ton. So we don't have a 110 column. So we're going to kind of extrapolate between the 105 and 115. And then we said 72 indoor, which we don't have. So we're going to go between the 70 and 75. And then 63 wet bulb, which we do. So this column. So, and then the CFM that they're asking for is, let's see,
Looks like
1900 CFM.
Yeah.
Yeah. So again, we're gonna kind of round up to the 2000. So here, what we could do is we could just kind of look at the 115 and say, okay, well, I can't give you the 110, but I can tell you when it's 115, when it's even hotter outside, this is what my performance is going to be. So at 115, and then let's go down and say the same thing. Let's say they wanted 72. Let's look at 75. So when it's 115 out and 63 is the wet bulb, and it's 75, and we've got our settings at 2000 CFM, we're going to deliver 49.2 total cooling BTUs. And they're asking, and so using that calculation, they actually don't list the total up here. They say they want 34.64 sensible. So we're going to have to figure out that sensible cooling using our calculator. So we've got 49.2 times 0.84, which you see that right here, and that's going to give us 41.3. So we're actually providing a lot more cooling than they're even calling for with this 5-ton.
Okay.
So that's a scenario where we may even go back to the engineer and have a conversation and say, hey, you know, you selected a 5-ton piece of equipment, but you really are only shooting for a 34,000 BTUs. Ours is providing more than that. Maybe we look at the 4-ton, because you don't want to provide way more cooling than they need. You know, you want to meet it, you want to beat it a little bit, but if you provide an excessive amount of cooling, what's going to happen is that system is going to hit the set point very quickly and then turn off. And then it's going to get warm, and then it's going to turn on again, cool very quickly, and then turn off. So instead of cycling, 60 times a day, it's going to cycle 120. And so you're going to put a lot more wear and tear on that unit. Bigger is not better in air conditioning. You want to size it to the heat load as close as you can, go over a little bit so you make sure you're covered, but you don't want to put, if it's a 3.5-ton application, you don't want to put a 5-ton on it and think, oh, I'll be really comfortable. This will be great because I have way more cooling than I need. The opposite is true. So, we could look and say, boy, this engineer may have oversized this equipment. So we could just take the same information and kind of go up to our 4-ton, okay? And let's look at that 115, 75, 63. So 115 outdoor, 63 wet bulb. We're going to come down to 75, and I'm going to use the 1800. They called for 19 CFM. I'm going to use the 1800 CFM. And so that's going to take us right here to 39.7 total. And we're going to multiply it by our 0.9, which is our sensible calculation. That's going to give us 35.73. So this may be a 4-ton application, and the engineer may have oversized the equipment.
Okay, that's helpful. Okay.
So that's where we can be of value and bring a service to our customer. I go back to them and say, hey, this is, provide them this expanded cooling data and an interpretation of it, and saying, hey, you selected this, but you may be setting yourself up for short cycling at this 110. And so, yeah, I mean, that's kind of how the math all translates.
Okay.
So that's expanded cooling data. Now, the rest of the package we're going to look for is the accessories that they want. So model number designates that unit shall be equipped with low ambient operation kit. So they want a low ambient kit, a return air smoke detector, and a service outlet. So what I would say to anyone on the call, once you start seeing this kind of verbiage, 100% get me involved, because all of these are factory options. In fact, probably the easier way for me to say it is I would expect a experienced TSM to be able to quote the equipment, to go through the selection like we did and say, okay, I've sized this right. I've picked the heat pump. I've picked the gas pack, you know, to select the equipment, select the proper curb, or use CDI curbs to select the proper curb adapter. And then also to be able to quote either the manual damper or the economizer. Those are very common in commercial. In fact, fresh air is required in all commercial applications, a fresh air intake. Whether they do it through our equipment or there's a second piece of equipment that they use to bring in makeup air. There's dedicated units that do that, or, you know, you have ERVs, energy recovering ventilators that can perform that function. So when I say it's required, a manual damper is not required and an economizer is not required necessarily, but what they do is, so they've either got to provide it some other way or they've got to get it from us. So, you know, an experienced TSM should be able to quote the equipment, select the appropriate curb or curb adapter, and then select the appropriate manual damper or economizer. Once you get beyond that, those are kind of very much cookie cutter, change out, commercial add-on replacement service opportunities that TSMs, you know, I would want each TSM to be on target to gain the experience to be able to quote that.
Okay.
Beyond that, you're getting into a lot more complicated factory options and selections. And so that's where it's a really good idea to get me involved, because, you know, that's my wheelhouse. That's where I live and breathe.
Okay. So can I take advantage of, you know, like right now, I think this is a great start to say, okay, here's the basic stuff to look for. Can we set up a follow-up and just do a training on CDI curbs and how to do that? And also a training on the configurator tool, and we'll just separate those out so we can, again, the audience can kind of take the time and watch this for 30 minutes and get themselves familiar. Is that okay?
Yeah, that sounds great. We'll do one dedicated 30-minute CDI curbs one, and then we'll do one dedicated. When you say the selector, you mean the commercial submittal tool?
Yes.
In PartnerLink?
Exactly. Yep.
Absolutely. I think those are great ideas, and those are really fun kind of pieces of technology that makes life easy for a TSM.
For sure. Okay, great. We'll do that. So that's to come.
Okay. Okay. So I guess we can put a pin in it there. Is there any other questions you wanted to ask or anything else you wanted to cover?
Nope. I think this is a great start. Thank you for giving me your time, and we will have more to come. So I'm excited. Thank you.